Okay, we're going to start with number 17. Just so you know that this is the audio is recorded over the video, so it may not match up exactly. So anyways, we got a product of matrices BAB, and the entire matrix BAB has size 19 by 7. Alright, so there's two matrices we're dealing with. We got B and we got A. Now matrix B will have M by N, size M by N. Now A, we're not sure what it is, but it must have N by something, because you got to see that in order to multiply matrices together, the two ends have to match up. Now when you look at the B on the outside, it's going to help us figure out what the other dimension to A is. So again, you see how these ends have to match up for those matrices to multiply together. These two also have to match up, meaning that the question mark has to be an M. Okay, so what am I doing now? Okay, so anyways, when you multiply matrices together, the product size will have to be the first number and the last number, because that's how you multiply matrices. So that's how the whole thing is 19 by 7. Well, notice that if M is 19 and we just saw that N has to be 7, we can then just start plugging numbers in, or filling in the blanks, really, to make sure everything matches up. So notice everything matches up, which means that B has to have size 19 by 7, A has to have size 7 by 19. Okay, now this one's 25, and it's discussing when matrices are invertible. Now, in order for a matrix to have an inverse, a 2 by 2 matrix has a special condition to it. And so that condition just has to deal with those letters A, B, C, D. So here's how the condition works. So if you take A times D minus B times C, if that does not equal 0, so if AD minus BC does not equal 0, then... Oh, it's not stopping. Okay, I can't zoom out. Then the matrix is... Now this is going to help with number 26, because it's a 2 by 2 matrix, and it's going to have to satisfy the same condition. So let me go ahead, let me go find out what the matrix for 26 is. Okay, so it's 4, 12, 6, and X. Now, the matrix has to satisfy the AD minus BC doesn't equal 0. Oops. Okay, well anyways, that will help you solve for X. Anyways, moving on to the next question. This is number 8. This is about finding the inverse to this matrix here. Now you can use the graphing calculator, or you could do it the long way we've done in class, which is to append on the identity matrix onto the end, and then what we're going to do is row reduce this left-hand side, so we get our columns or our diagonal of 1s. So let's start with changing that one to a 1, which it already is. So we're going to set up our new row operations. Our first one will be row 2 minus 3 times row 1. And you should write these out. But as I'm doing it, I'm just doing it more in my head. So we're going to get 3 times 3, which is 0, 7 minus 6, which is 1, 4 minus 3. So there's 4 minus 3, which is 1. Then we'll have 0 minus 3 times 1, so negative 3. 1 minus 0 times 3, that's 1, and then 0. Okay, and I'm not changing anything to row 1, so I'll just rewrite row 1 in there again. And then we'll do our operation with row 3. So that's going to be row 3 minus 3 times row 1. So it'll give me 0. This will give me 3 minus 3 times 2, which is 3 minus 6. There you go, which is minus 9. And then minus 5 minus 3 times 1. This is what I mean by writing it out, so you're less likely to make mistakes. Then we'll get 0 minus 3, which is minus 1. I'm sorry, minus 3. 0 minus 0, and 1 minus 0. Alright, so there's our first set of operations. Let's go ahead and start our second set. We got to make that into a 1, which it already is. So we're ready to do the operations with row 1 and row 3. So there's our pivot element. So we're going to do row 1 minus 2 times row 2, because again we need row 1 and then we need that minus 2. Okay, so we get 1 minus 2 times 0. That's 1. And we get 2 minus 2 times 1, that's 2 minus 2, that's 0. Then we'll get 1 minus 2 times 1, which is minus 1. And we got 1 minus 2 times negative 3. This is again why you write it out, because we have a lot of negatives here. So 1 minus 2 times negative 3, that's 7. Then you get 0 minus 2 times 1, it's minus 2. And then 0 minus 2 times 0, which is 0. Okay, we're not changing row 2, so let me rewrite row 2 in there again. Alright, let's do the row 3 operation. So that's row 3 plus 9 times row 2. Okay, so let me get rid of this. And then we'll start the next set. Okay, so first one's going to be 0. Then we're going to get minus 9 plus 9 times 1. That's also 0. We'll get minus 8 plus 9 times 1, which is 1. And we're going to get minus 3 minus 3 plus 9 times negative 3. That will be negative 30. There's going to be a typo here. Yep, so it is actually negative 30. I will fix this later in the video though. Then we got 0 plus 9 times 1, that's 9. And then 1 plus 9 times 0, which is 1. Alright, so there's this set of operations complete. Now I'm going to have to pivot around row 3's 1. Let's go ahead and do that now. So what we're going to do is we're going to do row 2 minus row 1. Because if you subtract them, they'll be automatically 0. I'm not changing anything to row 3, so I'm just going to write that back in. Again, that should be a negative 30, but I will fix that later. Alright, so let's do our operations now with row 2. So 0 minus 0, 0. 1 minus 0 is 1. 1 minus 1 is 0. Alright, negative 3 minus 30. Oh, see, now this is where I found my mistake, because it should be negative, so it's minus 3 minus negative 30. That's minus 3 plus 30. There you go, 27. Then we got 1 minus 9, which is negative 8. And then 0 minus 1. It's negative 1. Okay, now to our last operation, which will be row 1 plus row 3. Notice that when you add those two together, you'll get 0. Alright, so this should be a quick one. We get 1, 0, 0. 7 minus 30, which is negative 23. Negative 2 plus 9, which is 7. And 0 plus 1 is 1. So right here is our inverse. Again, that should be a negative 30 down there, which I'll... don't worry, I figure this out in a second. There we go. Okay, so that's the inverse. So now if you want to check it, what you can do is take that and multiply it to the original matrix up top, and this, when you multiply them together, should give you the identity.